This is the basic skills review, and we're going to start with fraction operations. First, if you have any mixed numbers, you want to convert all mixed numbers to improper fractions before you do anything with them. Once that's done, to multiply fractions, you cross-cancel if you can, if it's possible. Then you multiply numerators, let me abbreviate that, multiply numerators, and then multiply denominators. And if you have cross-canceled everything, you shouldn't have to then simplify. To divide fractions, we keep, change, and flip, meaning you keep the first fraction, you change multiplication to division, and you flip to the reciprocal of the second. And then you just follow the rules for multiplication. To add or subtract fractions, you must have an LCD, which is a least common denominator. Now, there are a lot of fraction practice problems on the practice sheet provided with these notes. All right, let's look at exponents and quickly go through, again, reviewing the rules for exponents. I will give you the name of some of these, but I'm not interested in whether you know the name. I'm interested in, do you know how the property works? So the first one, number 1, is called the product rule, and it says when you are multiplying like bases, so you're multiplying and your bases are alike, you add their exponents. An example is 2 to the 3rd times 2 to the 4th will be 2 to the 3 plus 4, or 2 to the 7th. The next rule is the power rule. That's when we have one base, but its exponent is raised to an exponent. So you have a double exponent on the base, and the rule is you multiply those exponents. So 2 to the 3rd power raised to the 4th power would be 2 to the 3 times 4, or 2 to the 12th. Our next one is, I think the next one, and along with it, number 6, they kind of go together. I think these are kind of intuitive, and that basically says if you have more than one thing in parentheses with no plus or minus, it can only be multiplication in parentheses, and you have an outside exponent, that exponent belongs to everything inside. So for example, if I had 2x raised to the 3rd power, the 2 is raised to the 3rd power, and so is the x raised to the 3rd power. 2 to the 3rd is 8x cubed. So the exponent belongs to the parentheses, so it belongs to everything inside those parentheses. This next one is the one that people get so confused, and that is a negative exponent. And a negative exponent, as you can see right here, has nothing to do with a negative number, but instead means reciprocal. So if I have 2 to the negative 3, what that means is the reciprocal of 2, which is 1/2, raised to the positive 3, which would be 1 to the 3rd over 2 to the 3rd, or 1/8. Now notice something. If I just had 2 to the positive 3, that would be 8. And 8 and 1/8 are reciprocals. So that's why that negative exponent refers to a reciprocal. The next one is called the quotient rule, and it says if you are dividing like bases, you subtract the exponents. So if I had 2 to the 7th over 2 to the 3rd, I keep my base 2, and then I subtract 7, take away 3 is 4. 2 to the 4th is 16. 2 times 2 times 2 times 2. Number 6, I said, goes with number 3. It's just an example of an outside exponent applied to a fraction. So if I had 2 over x all raised to the 3rd power, that means 2 to the 3rd power over x to the 3rd power, or 8 over x cubed. This is an important one. That is if we have a negative exponent on the outside of parentheses where I have a fraction inside, that negative exponent again means the reciprocal of my fraction. So if I had 2 over x to the negative 3, that means the reciprocal of 2 over x, which is x over 2, to the positive 3. Or x cubed over 2 cubed is x cubed over 8. Finally, we have the zero exponent rule, which says anything to the 0 power is 1. So if I had 2xyz squared all to the 0 power, it is still equal to 1. Anything to the 0 power is 1. And since the 0 applies to that whole parentheses there, then that whole thing is just equal to 1. All right, last thing I want to review quickly on our basic skills review is operations with polynomials. So to add polynomials, it's the easiest. You are just combining like terms. Exponents don't change. You're just adding like things. To subtract polynomials, you change to addition. So the subtraction sign becomes addition. And then you change all the signs on the second polynomial, and then you just add, because now you're adding. So now you would go back and combine like terms. So I'm going to put combine like terms. But don't forget to change the signs after you change subtraction to addition. To multiply polynomials, if it's just a monomial times another polynomial, you're going to multiply the coefficients and then multiply the variables using your exponent rules. But if it's, let's say, 2 binomials, you're going to use the FOIL method. First, outside, inside, and last. Finally, to divide polynomials by a monomial, you split the fraction into smaller fractions over the common denominator. How many smaller fractions? However many terms are in your numerator. And so I'm going to put over the LCD that they already have, so they're sharing that denominator, and then you just cross-cancel using your rules of exponents and cross-canceling and simplifying fractions.